Terzaghi reminded us in 1926 that we must not forget that soils are granular materials, otherwise we are condemned to making important mistakes. And even though great researchers from Coulomb to Rankine to the continuum mechanics have adopted the continuous material metaphor, if we really want to understand soil behavior, we must go back to the fundamental, which is soils are granular materials. And we may not be able to see the grains, but the essence of the behavior is granular. Therefore, let's start from this fundamental concept that soils are granular materials, and let's see what are all the implications that come along. So, for example, one of them is that size and shape play an important role, whether they are very platy particles, which are actually not prismatic like that, but we will see more about phyllosilicates in future meetings, or a freshly crushed granite that give us very angular shapes. We go back to the essence that soils are granular materials. The next consequence of that is that grains do not fit perfectly against each other. Therefore, soils are inherently porous. Furthermore, all the pores are interconnected. Consequently, soils are inherently permeable. Now we can think of grains, and really the metaphor applies also to fine-grained sediments, but we can think of grains as soccer balloons, and if we step on a soccer balloon and we put a load, the deformation will concentrate at the tip, flattening the tip. And so there is lots of deformation at the beginning, and then it gets stiffer and stiffer, more difficult to deform. That means that little force can cause large deformation at the beginning, but decreasingly smaller deformation as the force increases. That means that soils, because they are granular, they are inherently non-linear. Now, if we take a soil packing and one grain displaces relative to the other, and there is slippage at contacts, we cannot go back. So soils are inherently non-linear, non-elastic. And furthermore, the interaction between grains is of frictional nature. Therefore, the whole properties of large deformation will be inherently controlled by interparticle friction. So soils are, because they are granular, they are frictional. Now, if you compare this granular packing with a loose packing, for example, one that looks like that, then we can conclude that under certain conditions, the soil will have to go up to override the particle, or it may fall in the voids. So there will be volume changes upon shear. Now we can assign to each one of these properties the name of some theory. For example, this will be Darcy. This will be Hertz. This will be Mindlin. Frictional is what Coulomb told us in the 1776. And this is the beginning of what became eventually some form of, it became embedded in critical state soil mechanics. This is the concept of dilation. or contraction upon shear. Now, folks, something that we forgot to highlight in this sequence is at this point we were looking only at the soil grains, but we forgot to look into what is in the voids. So there is a coexistence of the mineral phase with the fluid phase. So there is a fluid phase that fills the voids, and that fluid phase could be a single phase or it could be multi-phase. And that gives rise to unsaturated soil behavior. Now we have a problem. If we have the coexistence of a fluid phase and a mineral skeleton, and we want to see what controls the deformation, the shear strength, the tendency to contract or to dilate, all that will be determined by the load that is carried by the granular skeleton. And so one consequence of soils being granular materials is that effective stress, or we can call the stress carried by the skeleton, the granular skeleton, is critical to understanding the behavior of soils. Because we are going to see that all mechanical properties and other properties like thermal conductivity are intimately determined, dependent upon the effective stress that the granular skeleton is carrying. This is such an important conclusion of our very first statement that soils are granular materials. Therefore, all these consequences are inherently linked to this fundamental observation that Terzaghi rightly pointed out 100 years ago.